Hi girls, this is your awesome sick teacher again. Although I'm not sick, I'm just away for a conference. So today, let's look at the second part of your log function. So here is the very important recap, in case you didn't quite listen to Miss Davis before. So the first thing is, how do we actually define log function? So we started with exponential function. For example, if y equals to e to the power of x, then it's equivalent to saying log base of e of y equals to x. In other words, you are making the original index as your subject. Okay, so how you read it? E to the power of x equals to y. So they are actually equivalent. So you are told to learn, or you have seen this log law before. Law, oops, just rewrite it. Log laws. So the very first thing, of course, important, log of xy is equals to log x plus log y. Now, even though I'm just writing the log base of e, but these log laws is actually true for any base. But I'm just using base of e for convenient purpose. This is very important. You can bring the power down if inside the power. Okay, and there's some very important result as well, which is 0, because e to the power of 0 is 1, and we're going to use this kind of idea very soon later on. Okay, and log base of, let's say, e to the power of, oops, that is 1, because e to the power of 1, it's e. Okay, very important. Next one, we have the change of base rule. Imagine if you have a log base of a, let's say of b, which is not what you need to. If you want to change it to any base you like, let's just say base of e, put the bigger number at the top, divided by log base e of a. So this is the famous change of base rule. Okay, some notation. Remember, ln is exactly the same as log base of e. And in Cambridge book only, all the log you see is the same as this, which is ln. Okay, not the same thing on your calculators as log, because the calculator log has a base of 10, which we rarely use now. Okay, so let's take a look what we need to do today. First of all, the curve of log function. So imagine if we have the function y equals to log of x. There is a general form of this curve. First of all, we need to know any number you put into log has to be strictly greater than 0. Why is that? Because no matter what power you get, you won't get a negative number if the base is e. E to the power of 5, e to the power of negative 2, e to the power of even negative root 2 on 3, something like that, etc., etc. You can't get any number that is negative. Therefore, the input you put it in here has to be positive. Otherwise, you can't get e to the power of y equals x. Okay, so therefore now you need to know the general shape of the log curve. Now, what is the x-intercept of a log curve? The x-intercept is whenever y equals 0. If we let log x equals 0, therefore e to the power of 0 is equal to x. What is your x? Of course, that's 1. Because when y equals 0, x equals 1. It reflects the knowledge e to the power of 0 equals 1. So that is basically the general shape of a log curve. Now what we need to do is the transformation. Transformation of curve is exactly the same as what I taught you in exponential function. So we will be doing most likely reflection plus shifting. There is one more transformation skill. We'll mention it more in trigonometric function, but we don't use this a lot in here. So for example, when x is replaced by negative x, it reflects about the y-axis. Why y-axis? Because it's a horizontal flip. So therefore you have a function original is like this here. Oops, my bad. If the original function is here, then the next one here will be reflected about the y-axis. If x has been replaced by negative x. On the other hand, if y equals replaced by negative y, it reflects about the x-axis. It's a vertical flip in here now. Okay, so that's the transformation and shifting. If x is replaced by x minus h, it shifts to the right by h unit. Remember, we have gone through this before in exponential function, which is the same thing now. If y becomes y minus k, then it shifts upward by k units. It depends on what number you're minusing. If you're plusing a number, that means it's shifting to the negative direction. Okay, so let's take a look at an example. Let's sketch y equals to log x. Simple. Second one, x minus 4. C, y equals to negative log x. D, y equals to log of negative x. E, y equals to log of 4 minus x. Okay, so let's take a look. How do we actually do these things? Remember, the most general one we actually need to use for all the curve would be the first question, which is y equals to log x. The y equals log x curve is the most general one you're going to use for all of these. Therefore, that is the one. Okay, exactly the one we drew before. Second one, we want y equals to log x minus 4. Now this is a simple transformation by shifting because we have replaced x by x minus 4. So if it's x minus 4, now your curve has shifted to the right by 4 units. So therefore, the original asymptote was 0, now it's just 4. And it has a function like this, and that would be 5. Like that, drawn that way. Okay, so just simply shift it to the right by 4 units. Next one, we have y equals to negative log x. Now this is a little trap in here. Even you see a negative on the right hand side, it doesn't mean it is reflected about the y-axis. It doesn't mean it's horizontal flip, because this negative actually should go with the y, because it's not inside the x. Sorry, not inside the log function. As I told you all the time, the correct understanding should be this one. And now you know it's originally like this, because we have changed y become negative y, so this is a vertical flip. So it's a vertical flip about this curve. So it's no longer just going this way. So this is still 1. Still 1. Okay, now part D. We have y equals to log of negative x. Now this time, if it's actual x replaced by negative x, therefore it's a horizontal reflection. So originally the curve was like this. Now if you flip it horizontally, it's just going this way. Instead of cutting 1, you have -1. So that is the actual curve for this one. Now the last one here we have y equals to log 4 minus x. Another one, this is a big trap because you have to understand it in this way. Even though you have a positive 4 here, doesn't mean it's moving to the left by 4 units. Because remember what I said, both x and y need to be positive single coefficient at the front of the bracket. If it's not, you make it. So therefore, in this case, remember, we have to deal with reflection first and then about shifting. So this negative here represents the curve has to reflect about the y-axis, horizontal reflection, that gives you -1. And then this whole system in here, this curve, has to be moved to the right by 4 units. So now again, this asymptote is no longer just 1, no longer just 0, it should be 4 because it's been moved to the 4 by 4 unit. And this is just 3 now because it's 1 unit to the left of this. And if you want to find out what this is, you put a 0 in to this original function. That is log 4. Log 4 is simply just a number, even though it looks like a variable, but it is not. Okay, now let's take a look at another extra example, which I didn't put it in. Let's just try to make it a little bit more funny. Let's make a minus log x plus 2. Okay, now the very first thing is this 3 and this negative, both of them have nothing to do with your log function. So let's move it to the right side. So that becomes y minus 3 and a negative in here. So in other words, this reflection has nothing to do with the horizontal. It's actually vertical. So the original curve is like this. Now if we change it to vertical, we go this way. So by reflecting the curve from the top to the bottom, we have used the information about this negative sign. And then after that, you have to just do your shifting. And do remember, your original shifting of y and x, doesn't matter which one you do first. Let's go x first. So therefore, it's 1 in here. Now shift it to the left by 2 units because it's plus 2. Now your asymptote is no longer at 0. It becomes at -2. And when you cross that, it should be 1 unit to the left. Therefore, that is before you move it up by 3 units. So if you move it up by 3 units now, that would look like something like this. And you have to mark this point. This point has to be -1 and 3. Because original one here is 1, 0. It shift to the left by 2 units and shift up by 3 units. That's how you get from 1, 0 to -1, 3. That would be the point you want to mark. And if you want to find out what this point would be, again, just substitute 0 in here, which is 3 minus log 2. If you let x equals 0 for the original function. Okay. Okay, girls, let's come back to the second part of the lesson in the next video.